All right, we're going live. We're going live. We're going live. This is always really, really exciting. This is so exciting. I'm going to put my sunglasses on. We are definitely live. What's up, everybody? We are here for a very extra special Data on Kubernetes session. That's going to be an intro to persistence, talking about storage, getting some of the background groundwork under our belts to get started with this, because we understand that working with data on Kubernetes, if working on Kubernetes is a challenge, working with data on Kubernetes brings an extra special set of challenges. But that's why we have two amazing guests here. I'm going to dedicate our wrap before we get started out, just so we can get the right amount of energy. Remember, you can get your questions and comments going in the YouTube chat. We'll be happy to address them there. I was just talking to the speakers as well. If for whatever reason we don't get to address some of those questions here in the session today, we can continue the conversation on Slack and get those answered later this week. So let's start out with a little acapella rap. You can call us Robin Hood because we're taking down the sheriff, about to go into storage with Kunal and Eric. Clerical errors aside, we bring in persistence to the game, take these speakers, go up to 11 loud and clear with volume claims. So keep the questions flowing like Nile Tigris and Ganges, make awards go down. We're clearing out the Oscars and Grammys. That's how we do it. Sunglasses come off now. We're deleting rap mode. But that being said, got to start out the right way. As I said, we have two amazing speakers with us today. We have Eric Zietlow, we have Kunal Kushwaha, both very experienced practitioners, both very experienced content creators as well. You can check out Kunal's YouTube channel. Eric's got plenty of stuff too on YouTube talking specifically about this topic. But just to introduce both of you really quickly, Eric, who are you and what are we going to be talking about today?
Yeah. So I'm generally, we'll call me a tech enthusiast, someone who's been in the industry for a while here. Been in Kubernetes distributed systems for a number of years. Before Kubernetes, I was actually working on distributed databases. So again, data persistence was kind of my life. Apache Cassandra, for anyone who's heard of it, I was working with that for many years. So I do a little bit of a lot of things as well. Been a software engineer, been a network engineer, been support, you name it, I've probably done it. So.
And Kunal, just for folks who may not know who you are, although I feel like that's increasingly unlikely, but just give us a refresher.
No, it's very, very likely. Hey, everyone. I'm Kunal. I am a CNCF ambassador, and like Bart mentioned, I do content creation. Currently doing developer advocacy stuff at Civo Cloud. And I host we have the CNCF student community, which is what this session is in collaboration with. So we have some nice, folks in the community, and we do cloud native sessions and webinars just like this one. I do have a YouTube channel. It's called Kunal Kushwaha Only. So there I post tutorials and workshops. And I love communities. I love open source, and that's pretty much about me.
All right, very, very good. Eric, just to get a little bit of context, what makes this topic of data on Kubernetes so tricky for folks as an entry point? What are some resources that you might recommend? What's the best way to get started with this?
Yeah. So the first thing from resources perspective, Kubernetes docs. I know it's kind of cliche, but they are actually really, really good. Well filled out docs that talk about pretty much everything we're going to talk about today, all the different components. We're going to kind of build a chain of infrastructure, if you will. And all of those components can be found in the docs. I can actually provide links as well when we're talking about them. Why it's important, this is the direction the world is moving. There's definitely been a trend towards containerization, and now there's a trend towards stateful containerization, which I don't want to spoil anything for later, but this is really the way things are going. So.
Very, very good. And Kunal, in your case, how do you get started with Kubernetes? And then after that, one of the things that frequently comes up, and I'm sure it'll come up in Eric's presentation too, is we're talking about the difference between stateful and stateless workloads. Could you maybe touch on that? First of all, how you got into Kubernetes, and then, like I said, as an entry point into data on Kubernetes, what these two terms mean.
Sure. So with K8s, I'm a student. I'll be graduating next year. With K8s, I started, I was looking for some Java projects to contribute to. So I found this Kubernetes Java client, and it was pretty interesting by Red Hat middleware. I started contributing to that. That's how I learned about Kubernetes. I agree with the point Eric made. The documentation of Kubernetes is one of the best. It offers in-depth explanation, and I think it's definitely beginner friendly as well, because I started with that only as a beginner. Other resources I would recommend are, first of all, attend meetups like this. So you can ask questions related to, if you want to learn about data on Kubernetes, definitely stay in touch with the data on Kubernetes community. join the Slack channel and stuff. But there's also some amazing, speaking just about like specific Kubernetes stuff, you will also find plenty of amazing YouTube courses. Just Google Kubernetes resources and Kubernetes tutorials. You will find plenty. Just the important thing is get started. There's no best resource or anything. People say, hey, can you suggest me some best resource? I don't think there's this like any. Some people like learning from documentation. Some people like learning from, videos and tutorials. So it's totally up to, what you like to do. But yeah, that's pretty much about it. Speaking of like stateful, stateless applications, we can go on and on with that. But for those of you who are like, since it's a student session just starting out, I think you're familiar with Kubernetes. So if you are familiar, like you might know there are like pods and containers. So containers, basically your application is running in an isolated environment. You can imagine it's like a box in which your application is running on your host operating system. Containers like run on like virtual machines or whatever. You can scale containers, downgrade containers. One thing you may know is that by default, if there's any data in your container and your container, let's say, gets corrupted or gets deleted, so that data will be lost. For example, if you have I don't know if we have time to showcase a demo.
I can draw this all out on a whiteboard too. We can get into it.
Cool. I do think I have something, but anyway, it's going to take some time. But speaking more about it, Eric will show you a nice demo. He has a nice whiteboard and everything. The basic thing that I'm saying is let's say your application is running in a container, a box, and that container dies, gets deleted. Whatever, let's say you had a to-do list application and you had a few tasks listed. Those will be lost. Okay. Container will not store the state. So the stateless applications basically mean that, it's like an application and like a process in which the state does not get saved. So basically you have sessions of your application, right? Many people might be making requests or whatever. It does not depend on like previous sessions. The reference information about all the operations, it does not save that. Okay. On the stateful applications, on the other hand, it uses a database, for example, to store some data, or in simple terms, store some state from the client request or and use that particular request to make further requests. Okay, that information. So just in brief, the session information, when it's stored, like on the server, for example, that is a stateful application. In stateless application, no such application is stored. Every single operation you're making and things like that, and even in like containers and stuff, if containers die or whatever, you can definitely restart new containers without any trouble. That's like one of the advantages. So for example, if you're talking about stateless versus stateful applications, like Bart was mentioning. So in stateless, let's say it does not require your server to save the information about the sessions or states or whatever. In stateful, it does require to save some information related to the session. In stateless, another comparison we can make is like the design. So since it's not storing any information, the architecture is like simple as compared to stateful applications. Stateless applications, since they're not dependent on like such databases or whatever, then the crashes, when they happen, containers go down or whatever, you can just spin up new containers, your new instances or whatever. So crash handling is very like easier as compared to like stateful applications, in that you have in this, there's something called like high availability. The servers here are regarded like they're long living, and user would probably be like it does not like really. We can also talk about like the architecture. So like the scaling architecture, for example. So if you want to scale stateless applications, then it's much easier as compared to your stateful applications, for example. There are a few challenges when we're talking about like stateful applications. So for example, resources. So many containers that you may have, for example, they may have some resource allocation. For example, you might say this container should only run, let's say, this much amount of CPU or storage or memory. So if you have such containers, a stateless application, which will be much suited. But when it comes to like some stateful applications, then in that case, this can not be a very good thing, because there is now risk of losing data of like your customers or whatever, and have unreliable performance, for example. So another point can be like related to storage. So every like stateful application, like we mentioned previously, will need some sort of a storage associated with it. So like a file system or a cloud storage or whatever. Now it can be difficult to like determine like what kind of backup do you need for this, and if you want to migrate from one cluster to another cluster, how do you migrate like the database or whatever. And one more thing that such challenges exist is because initially the organizations like the applications, they were not designed like stateful was like coming like afterwards. Initial like stateless applications are very popular because they offer like your it's like very fast and like portability and everything. So it removes the overhead of creating and using sessions, and it scales horizontally very well. You can create new instances and there's consistency across applications. So that's like it makes it much more comfortable for maintenance and like to work with it. Both of to answer your question, like stateful versus stateless, which one would you use? It's not a this or that question. I think it totally depends on like the use case, what your application does, if you're maintaining the state or not. But yeah, I think if you have any questions, like, I mean, Eric can touch a lot more upon that as well. Yeah.
Yeah, we're gonna touch on a lot of that throughout the session here today. But yeah, really good overview. All right, I can jump right in.
Yeah, jump right in. Like. Thank you very much, Kunal. Great outline.
All right, no worries. Let me go ahead and share my screen. Give me 2 seconds here. All right, we're gonna try this on a whiteboard today. This is actually the first time I've done this live, so hopefully it kind of works out. All right, so y'all should be seeing a whiteboard now. So real quick in the chat, just so I can get some idea of how the level of the audience here, how many people have actually interacted with Kubernetes in production before? Can I just get a quick show of hands in the YouTube chat? And I'm realizing now that there's about a 5 to 6 second delay here. So try to keep things running with that. Okay. Once you've done that, just start yelling out different components that make up Kubernetes. So I'll start with one. I'm going to say the master is obviously an important component for Kubernetes. So let's throw that down. All right, so a master is basically a computer, right? It's a computer that is going to control all the other computers in Kubernetes. Okay, not totally beginner, not okay. So a lot of really intro level stuff here. It sounds good. We can work with that. So in Kubernetes, a Kubernetes cluster is just a grouping of computers that are all there to accomplish a job. You can think about it like basically a cluster with nodes in that cluster, and then a manager managing all of those nodes. And when we deploy a job, it basically sends that job to some compute resources. The jobs in Kubernetes are handled inside of pods and containers. These are terms we'll define a little bit better. But essentially, those jobs get sent out to a computer where they're run, and then if that pod doesn't need to live anymore, we can kill the pod. Or if that pod is maybe stateful, like Kunal was kind of alluding to, then we have to do some stuff to make sure data sticks around. So first off, we have a master. Next, we're going to need some workers. So I'm just going to, for example here, I'm just going to throw up 2 workers, worker, and I'm just going to make 2 of these real quick. And there. Okay. So we have our master, we have our workers, and generally what happens is these, the master and the workers all have subcomponents, things that help them to run. So the first thing on your master that you're going to have is the API server. Oops. Typing live is always an interesting endeavor. Okay, so your API server, that's how we as users interact with Kubernetes. When you go into kubectl, that's actually talking with the Kubernetes API server. A lot of the things you use that expand Kubernetes functionality will actually extend that API server and add additional commands you can run. There are also some HTTP clients to run against the API server. There's a lot of really interesting ways to interact. The most common one you're going to see, though, is through kubectl, and that will talk to the API server for you. So you can actually actually run kubectl apply and then apply a YAML and do everything that way. Next piece is going to be your controller manager. And controller manager is basically the thing that's going to work on kind of the jobs. It actually works alongside the scheduler. And together, those will take the incoming jobs, the incoming requests for work, and they will send them out to the correct workers. They basically work together to make sure everything ends up in the right location. Next, we have this thing called etcd. And etcd is kind of a secret sauce component here. etcd is just a key value store. It just keeps track of all the different components inside Kubernetes, how they're interacting, if you tagged it, if they're named, whatever those things are, so that you can reference them inside Kubernetes and other Kubernetes components can reference them. That's actually really, really important, because what we're going to do here today is we're going to basically make a chain of components that all reference the last component. So storage in Kubernetes, or persistence, the way we provide persistence, isn't just as simple as plugging in a USB stick somewhere. There's actually a kind of a path we have to follow down to get where we need to go here. So etcd stores all these relationships, tags, names, all of these things we're going to use to reference these different components. All right, next we have the star of the show in most cases. In Kubernetes, we have pods. And pods can be, there can be many pods per worker. There don't have to be many pods per worker. It could just be one or two. But part of the advantage of Kubernetes is that we can divide things up via pods. Now, pods are the smallest unit of distribution. What that means is you're not going to ever have a pod that spans multiple workers. A pod will live on a single worker and will function on that worker in physical space. So if we think about this from a storage perspective, and let me just grab here, let's say we have a hard drive, and this hard drive is connected to this worker. It's actually directly connected, right? The worker is just a computer. So this is the hard drive that's in the computer. And say if we want this pod to consume that hard drive, well, this pod over here would have trouble because it wouldn't be connected. It would have no connection to that pod. So this is important to keep in mind. We're going to look at a local PV instance of how to do this, which is local persistent volume, which means we're dealing with direct attached drives. We can get more complex and start adding in network drives, SANs, all sorts of things. We can take it very, very far. But for now, just to illustrate the simple concept, understand that we're going to have hard drives that are attached to the workers. Okay, next component. Just run through these really quick. We have a kubelet, which is essentially your Kubernetes process that runs on every node. It's the thing that when you look at a Kubernetes process on your node, you look for the kubelet.
Eric, got a quick question. One worker node can have multiple pods, right?
Absolutely, yes. And actually, depending on what your setup looks like, sometimes you'll have many pods in a single node. It just depends. So when just to use kind of the same example that Kunal used earlier, when you have like a to-do app, if you had, say, a really, really large scale to-do app and you had a ton of people hitting it, and it's a web-based, a web app, you're going to have a web UI, and you're going to need some sort of scaling to handle all of the loads. So what you can do is, say I have maybe like, I don't know, a small Kubernetes cluster, say 3 workers, 1 master. If I have 3 pods, and for some reason, all 3 pods are, each worker has 1 pod, but I need to scale this, what I do is I just deploy more pods. And then I could end up with, maybe 9 pods on my 3 workers, and it can scale out like that. So yeah, hopefully that answers the question. We have another question. Useful to bear in mind, smallest possible logical unit that can be deployed. Yeah, exactly. Pods are the smallest possible unit of deployment in one sense. The containers, we always hear about containers, containerization, Docker containers, Kubernetes containers. Containers are all the thing, right? Containers actually live inside of pods. So one pod can contain multiple containers, and I'm sorry, this is going to be too small, so I'm not going to write containers. Just use your imagination, and you know, we'll go from there. But a pod can actually contain one or many containers. Now, again, if you think about this, if you have containers contained in a pod and you deploy them, they're not going to end up on different workers. They're going to end up on a single worker, because the pod is the smallest unit of compute distribution. It's the smallest logical unit that you can deploy. Exactly. All right, let's see. Don't get the kubelet. Not sure exactly what that's in reference to. Is this session for beginners? Yes, absolutely it is. All right. Next, we're going to take a look at the C advisor. So, oops, Ed. I am hitting all the wrong buttons on my keyboard. Whatever. We will make it work. Whatever. I can't type. We'll just make that work. All right, so C advisor is basically local resource management for each of the workers. So when you have a worker, obviously we need to understand how much compute is available. So how much RAM and how much CPU, how many CPU cores are available on that worker. Now, when the job comes into the API server and the master says, I need to put this job somewhere, it doesn't necessarily know all the information about what's currently going on, but the C advisor is local to every single one of the workers and can basically report back how many resources are available, allowing the scheduler and the controller manager to make a smart decision and deploy that job where the load is, lowest, where the resources are available. So it's really important. And then the last component here is going to be the other kind of magic piece. And I say this, I say this as someone who's worked as a network engineer. In the past, when you wanted to connect two computers, you'd have, you wanted to set up a kind of a microservices architecture, you'd have to do a ton of networking to get there. You'd have to actually go physically plug in a bunch of switches, or if you had say maybe an AWS cluster, you'd have to sit there in the console, wiring the whole thing up, setting up your groups, and putting all the resources in the right places. Well, Kubernetes does something really cool. You remember how I said etcd keeps track of everything? In Kubernetes, every single thing you interact with, create, or that's just natively part of Kubernetes is named. It's referenceable via that name. And kubeproxy takes care of the networking component and obfuscates all of the actual IP addresses, all of the actual routing using etcd. So now I can reference a service. Or for example, if I have a load balancer and I need to do something with that load balancer, I can do kubectl and reference that load balancer by name and tell it to forward something somewhere, or I can take a service and expose that service to the outside world, and kubeproxy does all the heavy lifting for me. Really, really cool. Let's see. Looks like we have another question here. Oh, no. Looks like we have an answer. Awesome. All right. So next up, we are going to take a look at containers. So we talked a little bit about stateless versus stateful. What's the problem with this setup if I were running a stateful workload? Can anyone tell me? For example, let's say I'm running a database, and this pod right here is running a container, and that container has a database. Anyone in chat, they're able to tell me what the problem would be with that situation? Anyone at all? Looks like we have about 10 seconds of lag here between when I talk and the YouTube stream catches up. So we'll work with it. Once the pod dies and is recreated, it won't know what, yes, it basically has no way of actually storing that. So just like Kunal said, where if you had a to-do app and you store a bunch of stuff in the to-do app, and suddenly you take that pod down, or that container goes away for any reason whatsoever, now you've lost your data. Right? You don't have the ability to reference anything that pod had, because that pod doesn't exist anymore. It's ephemeral, right? So as soon as it goes away, it's gone. You could reapply the YAML you used to create that pod, but that's not going to bring up the same pod. That's going to bring up a new instance of it, a brand new pod, basically from scratch, 0 hour kind of just blank slate, if you will. So what we need to do is we need to create persistence for statefulness. So first thing we need to do is do what's called a stateful set. Now, a stateful set, let me see, I'm running out of room here. We'll just expand this up there a little bit. Okay, perfect. Stateful sets are the key component of defining something as stateful. Basically, every time a pod is deployed with a stateful set, it gives it a unique identifier, and that pod doesn't go away just because you took it down. That unique identifier is actually stored along with a bunch of state information, and then when you bring that pod back up, it actually brings up that same exact pod again. So instead of just bringing up a new image off the same template, we actually bring up the same pod. But this still has a problem, because we can't just store something in a stateful set and hope it magically persists, right? We actually have to have a place to store that. Now, in the what I was talking about earlier, we have hard drives that are attached to workers, right? You need to run your OS from somewhere. You need to actually have direct attached storage somewhere in this stack, unless you're in the cloud. But even with services like AWS, GCP, Azure, you can get direct attached drives on your instances. And actually, in many cases, it's a very good idea to do so. So we have a stateful set that's taking care of pod persistence, but it doesn't take care of data persistence. Data persistence needs to be handled a little differently. So the first thing we're going to have to do to access the physical storage on any of our machines is we're going to have to create what's called a storage class. Now, a storage class is a tool that Kubernetes defines that essentially allows you to say, here's where my storage is. So we're just going to call it SC for storage class. Actually, I should probably type that out. Storage class. Okay. Storage classes are a Kubernetes object. So when you go and you say kubectl get SC, that would give you a list of basically your storage classes, all the ones you've defined. Now, one of the complicated things, and this is why OpenEBS, Rancher Longhorn, and some other solutions exist, is defining your storage in a non-rigid way is very difficult. Either I have to know exactly what drive is connected and wire it up directly to the pod that I want it to live on, or live, I should say, next to. It's container attached, if you think about it. I need to wire that up directly, or I need to have a mechanism for doing that. OpenEBS and Longhorn both are tools for doing that automatically, but we're going to kind of simplify it here. I can talk about OpenEBS a little bit in depth at the end of this if people are curious. It's an open source project that I worked for Maya Data, who is the main contributor to it, for a while, so I'm pretty familiar with it. But yeah, there is a number of kind of nuances here. If you don't have a tool like Longhorn or OpenEBS, you're going to have to define everything manually. And as you can imagine, that's a pretty brittle way of doing things, but it does get the job done in a pinch. So we create a storage class, and in that storage class, we reference our actual resources themselves. So next, we're going to need a persistent volume claim. Now, the storage class just creates basically a resource where these persistent volumes can live. So I'm actually going to move this off to the side for now, because what happens when we have a pod is we're going to have a pod that's going to attach to something called a persistent volume claim, or a PVC. Oops. Okay, persistent volume claim is like a lease. And it's actually a Kubernetes object. The actual lease itself is a Kubernetes object. So the pod is going to say, I am connected to a persistent volume claim. Generally, this is defined in the YAML. And the persistent volume claim is going to say, I am a claim on a storage resource, right? Storage resource that's defined by my storage class. And that storage class is going to basically hand off a persistent volume. Now, Persistent. Sorry if I'm having any spelling errors here. I'm typing as fast as I can. So that persistent volume is what is actually the Kubernetes object that's basically wrapping your physical device. So let's say, again, this pod right here is a database. Or this container. So let's say DB right there. We're going to take, and it's going to connect to a persistent volume claim, which is going to connect to a persistent volume. And that persistent volume is going to be this hard drive right here from this storage class. Now, there are ways to create pools of devices and then consume things from those pools. That's one of the things that OpenEBS does, is it will actually create a pool of devices, and then it has this whole leasing system where you basically lease these devices, you can return them to the pools and do a lot of things. But again, that's maybe a little further than we're going to get to here today. Actually, we might actually have time for some OpenEBS magic. We'll see. But what we've done here is we've now provided a stateful container. Remember, we have this stateful setup here that uniquely identifies it. We have the persistent volume and volume claim that are associated with that. And those particular components are registered or registered is maybe not the right word. They are stored within the stateful set, right? The information, the path to the physical device that's going to store our info is now recorded in the stateful set, so we can get back to it. So now I can take that pod, I could kill that pod, and as long as I can bring that pod up in the same place or a place that has access to that persistent volume, I can get my data back. That's huge. That's really, really huge. So if I'm running a database, say I'm running, say Postgres, and I've got the single node of Postgres and my app relies on this, and oh no, something happened and that pod went down, I can bring that pod back up. It reconnects that entire chain, the persistent volume claim and persistent volume, and I am now back online. Now, you might notice I said a key thing there where it needs to have access. The pod needs to have access, because in just standard Kubernetes, there's very little to prevent my pod here from maybe spinning up over here. And if it spun up over there and this drive is direct connected to this over here, this worker might not have access to it, right? There'd be no actual path to get there. So that's where things like operators, and there's actually a lot of people who do Helm chart, kind of Helm charts with operators, which is basically a custom control loop sort of situation to make sure these things come up in the places where they used to be. That's getting to be much, much further down the road than we're probably going to get here today. But for now, understand, if you bring up a pod, you set up your persistent volume claim attached to a persistent volume that's attached to a storage class that has a physical device behind it, right? Then you can actually achieve persistence in a Kubernetes cluster. Okay, how are we doing on time here? Oh, wow, we're doing fantastic. I have about 15 minutes left. I can start taking questions here. We actually got through that way faster than I was planning. So in chat here, let me just see if anyone has any questions. Pod days, won't be able to retrieve data. Yep, absolutely. Database goes down, sorry, pod goes down. Yep. Okay, looks like we're all caught up on questions. Bart, did you have any questions here?
No, so far so good. Looks good. And also folks are helping each other out in the chat, which is also really nice. So keep up the great work.
Perfect. All right. Well, if you want, I could maybe show you kind of what OpenEBS would do in this sort of architecture and use it to illustrate.
We do have one question.
Oh, yep.
So if we delete a pod, doesn't that keep spinning up again and again until we delete the deployment of that? So does the data keep getting refreshed again and again? That's
really, really good catch. So in the situation where you're running a stateful set, generally you're running with an operator. Now, an operator is basically a custom control loop. What that means is you're actually custom defining the behavior of those pods. So yeah, you're entirely right. If we didn't do anything, we were using Kubernetes control loop and just letting it go, yeah, the container would go down. We wouldn't have state Let's just be clear on that. We wouldn't have any state stored, but that pod would just basically bounce, right? And that's not what we want. We don't want the fault tolerance of Kubernetes here is actually our enemy. What we want to do is we want to define a behavior where the pod will, if it goes down, maybe we can have it spin back up automatically itself, but make sure it's the same container, via a stateful set. Or maybe we don't want it to just come back up. Maybe we want to be, having to do some of this manually. It depends, but that's where custom control loops come in. And that's actually a really, really kind of key component to this. But yeah, good question. So we don't need to back up the data that we okay. Snapshots, backups, all of those things that are really, really good to do. And I will say this, no matter what, even if you're running a distributed database with redundancy, do backups. And the reason is quite simple. This drive down here is still a physical piece of hardware. It can still fail. That drive could literally just spin off the platters one day. It happens, and it actually happens a lot. So even though I have this entire chain, I have all this containerization, I have all this cool persistence that Kubernetes provides or could provide, depending on how we've configured it, I will still lose my data if that physical drive goes away. So do backups, create snapshots, do whatever you got to do to make sure that your data is safe. Backups are, yeah, exactly. Backups are always a good habit. Absolutely. I can't even think of an instance where I would tell you not to do backups. So back working with distributed databases, that was kind of a discussion that kept going around is, well, you have all these copies of the data. Don't you want to do, why would you need to do backups when you have these active systems that never go down and you can just bootstrap in a new node and never have downtime? Well, what happens when you have someone who goes in and manually deletes something, like does a truncate table or something like that, drop table, right? You always need backups. There's either human error or there's physical hardware issues that will arise at some point during the life cycle of an application. Always do backups. Yep, good question. Let's see. Do backups. Yep, always good habit. Absolutely. All right. Let me go ahead here and I will show you guys what OpenEBS does. Now, OpenEBS, like I said, is a tool to create pools of storage volumes that can be.
We got one more.
Oh, yep. What about consistency of the database? Will that somehow get impacted? Well, we can talk about Cassandra at some point. Cassandra is kind of the king when it comes to distributed databases. I will probably push that question till later. Consistency is actually a kind of a talk all of its own. It's actually really cool. Short answer is no, there's actually anti-entropy tools that will keep things consistent. It's something called strong consistency as opposed to an absolute consistency, but it's more than adequate to handle any concerns you'd really have. Another question, why is there a PVC and PV? How does using a PVC help? Oh, yeah, good question. So the PVC is the claim on the volume. The PV is the Kubernetes object that is the volume. So if you think about it, if you walk into a shop and you say to the shopkeep, I want one of those candy bars over there. That is the persistent volume claim. The transaction that happens, you giving them money in exchange for that object, and then you carrying that object out in your grocery bag is the claim of the object. The persistent volume is the candy bar. So basically, the pod has to lay claim that is referenceable, checkable. You can actually do a describe on a PVC and follow the path of where that claim runs. Think about it like a contract between the pod and the actual volume itself. Does that answer the question? Hopefully that does. And a little bit of lag here, so I'll move on and keep an eye on the chat. Okay. So in OpenEBS, we're actually extending the master. Oh, we got some more questions. All right. I don't know if we're going to get to OpenEBS. We'll see. Is it how great companies have the servers all the time running? As one crashes, the other automatically deploys? Yeah. So if you ever are in a situation where you need 100% uptime, there's kind of some methodologies and some thinking that you can employ to achieve that. And one of the ways was kind of the way Cassandra did it. That was actually one of the problems Cassandra was trying to solve. And one of the things you can do in Kubernetes with applications is you create active applications. So if you think about it in the context of Kubernetes, right, we have many workers, and these workers could be incredibly distributed. Like we could even run them across multiple providers if we really wanted to get crazy here. And so say if we had the worst happen and maybe like AWS or Azure or someone just crashed, like catastrophic failure, kind of apocalyptic event, right? But one of our other providers was online, we still have instances, reachable instances of, say, our web front end, if that's what we're running as some sort of a web app or something. We could have instances of that running in the other provider, and a load balancer that would know that the instances over here are down, those instances are up, and it would route you there. So it's active. You're actually able to interact with any and all instances at the same time, meaning that there's no downtime. Now, key thing to point out, you have to set it up that way in Kubernetes. You have to actually use the load balancer, have multiple instances of your app. If you just have a single instance of whatever it is you're running, like I had a web UI and I just had a single pod that just was running that web UI, and that went down, there'd be downtime, right? Because it takes time for that to redeploy. If I have Kubernetes control loop, then go and just auto redeploy that because it's unhealthy, and then the whole probe basically says that's unhealthy. Okay, redeploy. That takes time for that whole process to happen. So if you really want persistence, you're going to want to deploy multiple copies of whatever the stateless application is. Now, when we're working with stateful workloads, it's a little different, right? Because we actually have data. We can't just nuke something and spin it back up. So this is where Cassandra, there's some other databases that do some similar-ish things, but I'm going to talk about Cassandra because it's what I'm most an expert at. Where basically you have active nodes that handle consistency via quorum protocol. So basically they get a 51% consensus agreement across a cluster before they actually consider an operation successful. So using that, you can actually maintain correctness of your data, but you also get the advantage of you can lose entire portions of your database or access to entire portions of your database and still be online. And you can actually replace individual nodes, never going down. So similar concept, but the stateful versus stateless problem presents kind of a different set of challenges to each. Yeah. Let's see. Can you please explain persistent volume claims again in brief? Having a bit of confusion. Yeah, no worries. So a persistent volume claim, I'll use this. I'll use this as an example. If you buy a house, you end up having a purchase agreement and a title to that house. The purchase agreement and the title aren't the physical house. They're a record of ownership of that house. So you, in this scenario, would be the pod, right? You're the thing that needs the house to live with, to live in, right? So the pod, in this case, the person goes out and they purchase the physical object. The physical object, the house, is the persistent volume, and they get the claim, the deed, the title to that house is the claim that says they own the house. So if someone wants to check on my, who owns this particular piece of storage, we can check the claims and see which one I own. Or if you want to see what house I own, just go check my PVC, my persistent volume claim, and you can see which particular object, which particular volume I have ownership of. Does that make sense? Particular pod is right access physical hard drive. Yep, exactly. The PVC is actually generally defined in its own YAML. The PV is defined as well. Yeah, absolutely. All right, how are we doing? Got a couple more minutes. Bart, do you want me to take 15 minutes for questions, or do you want me to just keep going with this?
I think keep going, and then I think if there are questions that we don't get to, we can continue the conversation in Slack. So folks, keep asking your questions, but then we'll hang on to them. And like I said, if we need to continue the conversation there, we can.
Awesome. All right. So again, looking at OpenEBS. So this is the OpenEBS control plane. And it has a couple different components. It has an operator, which is basically a custom control loop. So it specifies a specific behavior different from the Kubernetes standard behavior of an object. So in this particular case, it's providing some persistence of some things we don't want to go away. If if we were to lose it, we wouldn't want it to just go away. We want to be able to bring up that same object again. We have the Maya API server. Maya API server extends the Kubernetes API server, allowing us to run kubectl commands that are specific to OpenEBS. So you can actually create OpenEBS resources using kubectl. It's actually really important for kind of an ease of use standpoint. Next, we have the local PV provisioner. And local PV provisioner is what actually goes out and provisions these persistent volumes. It takes that physical device and it creates this pool that's these Kubernetes resources. Because if you think about it, Kubernetes doesn't really care if it's a hard drive, if it's an SSD drive, if it's a SAN. It doesn't know. It doesn't care. It looks at this pool of resources. So local PV provisioner is what actually does that work for you. Okay. On the node itself, we have this other key component, and we're going to attach that to the kubelet. It's called NDM, or Node Device Manager. And what that does is that goes out and that will actually pool, just like the C advisor goes and pools compute resources on that particular worker, the NDM maintains the local pool of storage resources on that particular cluster and works with the local provisioner to create and maintain the pool of devices to be leased. So all of this stuff we had to do down here, instead of referencing something directly in our storage class, so instead of the hard drive being directly referenced, we just say our storage class and we define it as OpenEBS. And OpenEBS does all of that work for us, maintains that pool, and when we have a persistent volume claim, we just reference that storage class, which points it to OpenEBS, which points it to that pool of drives, and all of the leasing and releasing of drives happens from there automatically. Can we replace etcd with Redis? Oh, yeah. I don't think you can. I'm not 100% on that. I don't know why you would, first off. etcd is really, really lightweight. It's really, really good at what it does. It's kind of a very simple, durable key value store. I understand where you're going with, well, Redis is a key value store. Could you actually kind of plug and play some of these components? I don't think there would be any good reason to ever, at least nothing I can think of. Doesn't mean I've thought of every eventuality, but I wouldn't probably try it unless I had a really, really good reason. And I'm not aware of anyone, at least I've never heard of anyone doing it before. So, yeah. Okay, does that make sense though on OpenEBS, where it handles all of that drive discovery, all that pool management, that resource management for you, so you don't have to direct wire these things. It makes it a little more durable because, again, we would have to directly reference the physical hardware from our storage classes if we didn't do it with something like OpenEBS. Okay. Hopefully that was helpful. All right. Well, with that, I think that's about all I've got for you guys today. So Bart, I'm going to hand it off back to you and we can go from there.
Before we finish up, I think this was awesome because a lot of the folks that are in our community are, struggling with this notion of like, okay, I maybe touched a little bit of Kubernetes. I've done some stuff about microservices. I understand the differences when we're talking about different kinds of architecture, maybe an intro to containers, some knowledge about Docker. But then when we're taking this jump to say like, now we're going to talk about data on Kubernetes, and stateful data, stateful workloads, things like that, that's where things get a little bit blurry. So this is really helpful. Are there other things that you would recommend? We can leave resources aside for now, but in terms of the different, things that we've been talking about, clusters, pods, nodes. We've just mentioned etcd. We've also been obviously talking about PV and PVC, different things that are going to come up there. Other things that folks should keep in mind as they're beginning on this journey that were helpful for you, or that you find yourself frequently asked questions on Eric's side?
Yeah, absolutely. First thing I would throw out, and this is actually a resource thing, go to YouTube often. There's a number of really good YouTube channels out there on pretty much everything I've talked about here. I believe there's one, it's called something along the lines of like Tech with Nina. Yeah. There's Network Chuck. There's a lot of these people who are good at taking a beginner level approach to the content and just explaining it on a really, really, really informative, helpful, practical level. It's really easy to talk about all this stuff in theoretical terms, but when you can get someone who actually sits down and takes a practical approach to how would you actually go about doing this, for me at least, that's been one of the best resources I've found. The other thing, like I said, is the Kubernetes docs. And you know what? I'm actually going to link a couple docs. One on stateful sets. I'm just going to throw them in the chat here. Storage classes, and then persistent volumes, which is also going to have the documentation for PVCs. So go ahead and check those out. Oh, it might have blocked me. No, oh, they're there. Okay, perfect. If you need the docs, those are the Kubernetes docs on each of these different components we talked about. Highly recommend you read Kubernetes documentation. I know documentation is sometimes very hard to consume. Kubernetes does a very good job at trying to keep it simple, keep it understandable, and not use a ton of buzzwords. So highly, highly, highly recommend you read the docs when it comes to Kubernetes. Yeah, Tech with Nana. Yep, that's absolutely.
Yeah, you had also mentioned, because you had mentioned, Longhorn, and we had a session with Sam about that. So if you're interested in knowing more about that specifically, you've got that. We've also, the thing is, if you just type Eric's name in YouTube, you're going to find plenty of other talks that might build on the concepts that were mentioned here today with a bigger degree of complexity. I think also a really good point of what he says is, and we mentioned this a lot, read the documentation. It will give you the vocabulary. It will make you go research other things so you get more comfortable. And then what he was saying as well too is, I think the best way to be working on this is to try to put it into practice, which is why as a community, we're starting to now build out projects, and we're inviting folks to get involved in this so that we can directly apply the concepts that we're talking about. We have the videos, we've got the tutorials, we have the people with the expertise. So let's take those concepts and actually put them into action. So anyway, you'll see more things about that coming out on Slack. Any other questions from the audience before we finish today? Anything else you'd like to know? Career-wise as well, Eric, you've been in DevRel a lot. Is there anything else that you would give as general advice to someone who's worked a lot in developer relations?
Yeah, I'd say find something you enjoy doing because it's not a job. But that's fairly generic advice, but I think it really holds true. I got into developer relations because I had a passion for a specific group of things. That passion came out to the point where I was actually approached with this job opportunity. A lot of people in DevRel are here because we're passionate. We love what we do. We love the technology. We think it's cool. We actually get enthusiastic and fired up about these things. So, if you want to go to a DevRel kind of route, I would say find something that you can really, truly be enthusiastic about. And even if you want to just be an engineer or something a little more traditional, the same holds true. You can do a lot better job in life if you're excited to wake up on Monday morning and get to go play with cool stuff. I will throw out, just in case anyone wants to, it's just a resource I threw together. I used this in a previous talk, so we had lab instances, but through my learning, I just threw the link in chat there. Setting up OpenEBS, kind of the A to Z, just going down 3-node cluster, setting up an actual persistent volume, storing something on a persistent volume. Pretty simple overall lab, but check it out. Feel free to use it. Not, it's all up to you. And that's sponsored by Maya Data. That's stuff that they've sponsored content wise. So feel free to check it out.
Very, very good stuff. We got another question as well. People just asking about what exactly is DevRel. And this is good too, because is it marketing? Is it not marketing? Is it human resources? Is it just technical advice? How do you define it?
Yeah, absolutely not marketing. No marketing. What I am is I'm an engineer who gets to talk to other engineers and try to make them successful. I always make the joke, but it's really true. I try not to know even how much the products I work with cost, because I just want to find the best solution regardless of what those prices are. I love open source. DevRel is all about taking the passion and enthusiasm for technology out to other people and helping them to be successful with it. It's kind of a newer role. It's only been around for probably, about 5 years in its current form, about maybe 8 in really any form whatsoever. And it's really just about helping people, building communities, interacting on technology, and teaching. A lot of teaching in there. Looks like we've got another question here. Hi, Eric. You mentioned Cassandra is a database that's really good at a consistency requirement. Cassandra is NoSQL. What about SQL databases? Well, there are a lot of good, consistent SQL databases, but the key difference here is distributed SQL databases, not so much. If we're talking about actual active distribution in a database, you're going to need to go with something NoSQL. And you're going to, I would say, probably want to look at Cassandra as an option there. Yeah, okay. What's the difference between DevRel, developer or evangelist, and developer advocate? Well, developer evangelist is marketing's feeble attempt to become a developer advocate. Developer advocacy is DevRel. I consider myself a developer advocate under a DevRel umbrella. Yeah. Okay. Cool.
Cool. All right. Thanks everyone for attending. This was amazing. We'll have the artwork coming out a little bit later because our artist has another commitment today. But Eric is readily available in our Slack. If you want to reach out and ask questions, get some advice. I'm pretty sure we're going to be asking you to come back, Eric, to give some kind of a part 2 because this was really, really good. We got one more follow-up question before we finish. What about MongoDB?
MongoDB is not necessarily distributed in the same way. It's kind of a document store with sharding that's not the best way to describe it, but think about it more in those terms than to say a true distributed active database.
Fair enough. Good. Once again, thanks everyone for attending. This was very, very good, very interactive. Eric, you did an amazing job as always, as usual. So that being said, we'll finish that up for this. It's been our second meetup of the week. We'll have plenty more coming. You'll see all that on our website. If you haven't subscribed yet on YouTube, please do so. Check us out on Twitter. Lots of news coming out soon about things related to KubeCon. We'll be doing a co-located event there. Remember, we have all the instructions. If you want to write a summary about the session we did today, publish it on LinkedIn, give Eric a shout out, give the DoK a shout out. We'll be choosing the best summary and getting that published on our blog. So if you want to get published on the DoK blog, feel free to check that out. It's in our Slack. You can just DM me and I'll be happy to help you out with that. Eric, thanks a lot, man. Have a good one.
Absolutely.
All right. Take it easy, everyone. Take care. Bye-bye.